All right, let's dive into something really wild. We're going to tackle one of the most mind-bending questions in all of physics. And fair warning, it might completely change how you think about time.
I mean, really think about that for a second. We all kind of take it for granted, right? The past is done, it's set in stone, what's happened has happened. But what if that's not the full picture? What if a choice you make right now could actually reach back and change something that happened yesterday?
And look, this isn't just some late-night philosophical musing. It's actually grounded in real quantum experiments. Scientists have run these things called delayed choice or quantum eraser experiments. And the results, well, they're just plain bizarre. They seem to show that something we do in the present can literally decide what a particle did in the past. That totally upends everything we thought we knew about history being fixed. So yeah, that leads us straight into a massive paradox. It's this deep, nagging problem right at the heart of physics. And honestly, it's been bugging scientists for a long, long time. One of the key figures here is physicist Avshalom Elitzur. He's basically saying, hey, look at these quantum results. They force us to second-guess one of the most basic rules we live by, the idea that the past is untouchable. So the big question is, how do we make sense of this without completely breaking the laws of cause and effect?
Okay, so this is where a really interesting new idea comes into play. It's a framework called the Theory of Entropicity, or ToE for short, and it offers a pretty cool way out of this mess. It tries to explain those weird quantum findings without throwing the arrow of time out the window.
To really get this, we've got to totally rethink what we know about entropy. You know, we usually learn it's just a measure of disorder, like an ice cube melting into a puddle. But this new theory says, nope, it's way more than that. It suggests entropy is actually a fundamental field. It's not just a side effect of reality, it's the engine that's creating reality. It's not just describing things happening, it's the very thing that makes them happen. So how does this entropy field actually build the world we see? Well, the key to the whole thing is this really cool concept called distinguishability. Okay, here's the absolute heart of it. For anything to become real, to get locked into the past, it has to be clearly separate from all the other things that could have happened. And that separation isn't free, it has a cost, and the currency is entropy. You have to spend a certain amount of irreversible entropy to make it happen. It's like a cosmic transaction that turns a fuzzy maybe into a solid this is what happened. So it happens in a few steps. First, you start with this cloud of possibilities, all the different ways things could go. Then, boom, an irreversible event happens, like you take a measurement in an experiment. The theory calls this entropic closure. That event produces a burst of entropy, which creates distinguishability, and that act collapses that whole cloud of possibilities down into just one single, definite event that's now part of history. But here's where it gets really interesting. This whole process isn't random. There's a specific rule, a fundamental number built into the universe that acts like a gatekeeper for what gets to be real. And that rule comes down to this one little number, the natural logarithm of 2. Yeah, I know, it sounds kind of random. It's about 0.693. But according to this theory, this number is literally woven into the fabric of space-time. It represents the most basic choice possible. Is something in state A or state B? It's the ultimate this or that of the universe. This specific value has a name, the Obidi Curvature Invariant, or OCI. And you can really think of it as the price of admission to reality. It's the absolute bare minimum amount of entropic separation you need to tell two potential outcomes apart. If an event doesn't generate enough entropy to cross that LN2 threshold, the two outcomes just don't split. They stay blurred together in that fuzzy maybe state. So this OCI, this natural log of 2, it acts like a one-way door, a point of no return. Once an event generates enough entropy to cross that line, it goes through the door and gets locked into the past forever. And that is what creates the arrow of time we all experience, that hard, irreversible line between what's already happened and what's happening right now. All right, so with all that in mind, let's circle back to the paradox we started with, because now we have the tools to actually solve it. Let's ask that big question again. In those super weird quantum experiments, when it looks like our measurement in the present is changing the past, is that what's really happening? Is history being rewritten?
And the answer, according to this theory, is a flat-out no. The past is not being rewritten. But what's actually going on is, in my opinion, way cooler and more subtle.
To get it, you have to split the past into two different things. First, you have what's called the ontic past. Think of this as what actually happened, the raw physical reality of events.
And then you have the epistemic past. This is our record of what happened, the version we can actually know and measure. The crime scene analogy is perfect here. The ontic past is the crime scene itself, and the epistemic past is the detective's final report. And we all know those two things aren't always identical.
And that, right there, is the key. The measurement you make in the present doesn't go back in time and change the crime scene. It doesn't rewrite the raw, ontic past. All it does is provide that last crucial piece of evidence that allows the detective to finally write and file the report. It provides the entropic kick needed to cross that LN2 threshold. The particle's history wasn't rewritten, it just wasn't fully written down until that final measurement made it distinguishable.
So what does this all mean for how we see the world? Well, it suggests that history isn't some old book that's already been written from cover to cover. It's more like a story that's being revealed to us, page by page, moment by moment. So the universe isn't going back and editing its own history. Instead, that history is just slowly being revealed as these irreversible entropic events happen, separating one state from another. Each moment locks in another piece of the puzzle, building the grand story of our universe, all of it governed by that one tiny but crucial number, the natural log of 2.
And that leaves us with one last really wild thought to chew on. If the past only gets locked in when it becomes distinguishable, what does that mean for right now? As you're listening to this, what potential futures are still just possibilities? What's still undecided, just waiting for the next irreversible moment to lock it in as history? What piece of reality is being written right this second?